Good afternoon, everyone. Thank you for coming along to our talk, what we renamed at the very last minute to make it a little more appropriate for what we're going to do. So open source for busy people. We're going to live code a Flutter app today in the next 30-35 minutes. My name is Matt Sullivan. I'm a developer advocate at Google.
I'm Emily Fortuna, and I'm also a developer advocate at Google.
So perfect. What are we going to code?
Specifically, well, if there are any people in the audience that are like me that have SSH terminal apps on their phones, I think you imagine you need to have access to your computers at any moment. And if you're a open source project maintainer, you might need to review some pull requests. So we are going to be writing an app that allows us to review pull requests from your phone. And so you can accept them while you're on the go.
So you no longer have to have SSH on your phone?
Yes.
OK. So what we're going to do...
I'll still keep the app, probably.
And what are we going to call it?
Dude, where's my pull request?
So we're going to write an app which is going to basically let you review the pull requests that you've been asked to review, and hopefully, if we make it to the end, be able to accept or reject them. So before we get there, though, we're going to be writing this app in Flutter. So 30 seconds, what is Flutter?
Flutter is an open source APK that allows you to develop native, beautiful mobile apps for iOS and Android. You can see on the right, there are 4 different apps that are all written using Flutter. You can see they all look different. Flutter is designed to be very customizable, so you can make it look however you would like. And it's supposed to be easy and to write beautiful looking apps.
So that's great, but why are we talking about Flutter at OSCON? Well, it turns out that Flutter is completely open source. We do all of our work on GitHub. You can find it at Flutter/Flutter. We do all of our triaging. We do all of our issues. We do all our road mapping there. We try to do everything completely in the open. Flutter is also built to use the Skia rendering engine, which is also completely open source and used in a variety of different applications. So it's like Chromium, I think Firefox uses it, and a bunch of others as well. And finally, we use the Dart programming language to code and create our UIs, which again is completely open source and again is on GitHub. We're probably going to say GitHub an awful lot. So we do everything on GitHub, so hopefully our app will be useful to us. One of the nice things about being open source is that when I write Flutter, I tend to write Flutter like I used to write Python apps back in the day, in that when we ship the Flutter SDK, all of the UI in Flutter, all of the widgets, the UI components that we have pre-built, things like buttons and forms and AppBars and everything else, are all defined in Dart. And so we ship it with the source code, which means I at any point can go in and I can see how does Flutter build a button. And I like that, I know how to use it, but maybe I want to customize it a little bit, or maybe I want to have a custom app bar. I can go in, I can read the source, I can check it out. And it's how I used to do things with Python, where I'd see a library, I would go and read the source. And you'll see as we code this out that we'll probably refer back to the source or look at it through where you're going to use Visual Studio Code to do that. And that's what I like about one of the tenets we have for writing Flutter apps, which is to make it as easy as possible to be able to do this.
And I will say one more thing. Is a great thing is when I am debugging, if you're stepping through code bit by bit, because it's Dart and it's open source all the way down, you can step into the libraries themselves. You don't bottom out into some obfuscated native code that you can never figure out what's actually going on.
Great. So there's also the Flutter engine.
Yes. So the Flutter engine is also open, which allows us to embed it on a bunch of different platforms. We have embedders for Android and iOS. There are experimental ones for Linux and Mac. And there are whispers of other platforms. And because it's open source, you all can contribute to Red Flutter on any platform you so dream as well.
We have not only a bunch of people internally in Google contributing to Flutter, we have a lot of contributions from the community as well. We always encourage more. And you'll see that there's a thriving community who are building UI components on top of Flutter. And we're going to be using a few of those as we go through. So this is fantastic. We've done a bunch of talking. Be nice to actually get to the code. So we're going to be coding an app. So the first place that we're probably thinking about starting at is at the command line.
Yes, poor Matt. When he started learning how to use computers, they didn't have graphical user interfaces, so he's only comfortable with text, so that's where we're going to start.
What she means is I don't do design, because bad things happen when I do design. But what we want to do is we are going to be communicating with GitHub live over the network. Hopefully things will hang together. And so we need to be able to communicate with GitHub. So we're going to use the GitHub v4 API, which is new, which uses GraphQL. And so we're going to show you a little bit how we do that on the command line, just to get us going. And then we'll dive into the app. So I am going to start here with the simplest app in the world. We have a main, and we have, can everybody, is this big enough? OK, perfect. Basically, we have a 3-line main function which prints hello world. We have some imports and a couple of consts, and they're just here because you don't want to see me typing these as I start to do stuff. So,
yeah.
Great.
Not important for the hello world.
Not important for hello world. Where should I start?
Well, we should get some information about users from the GraphQL API from GitHub. So write a user function, and let's start writing our query.
OK, so what is GraphQL?
GraphQL is a project that came out of Facebook, and it allows you to specify the bits of information that you need from an API. So rather than your more typical RESTful format, where you might need to make multiple requests from one piece of information from a certain API and another from another, you can say, hey, I need information bits XYZ, and I want them formatted in this specific way, and it'll just hand it back to you. So it's a bit like SQL for API calls.
OK, so let's start with our query. I'm going to get a query string going here.
Yeah, so Matt is using the multi-line string form, which we have in Dart. And so just backing up just for a hair, we're using the Visual Studio Code developed IDE, and we're coding in Dart. And yes, Matt is going to be writing our query.
Our tooling team puts a lot of effort into making our support for IDEs as good as possible. We support Android Studio /IntelliJ. We also support Visual Studio Code. We have a really good Dart plugin, and you're going to see that in action here. So I'm going to start with the simplest GraphQL query. There we go.
There are Vim plugins if there's people like me.
There are Vim plugins if there's people like you and you use SSH terminals from your phone. So query, what are we going to look for? We're going to look for users. So let's pull that in. That's great. What do we want to get back from our user?
Let's get their login, their actual name, and then, well, we'd like to see their avatar. Although I know that you did download that ASCII art renderer for your command line, right?
I'm not rendering avatars on the command line.
Oh, okay.
So this is great. So here's a query, but we're not specifying the what user we're looking for. So we can do that. Let's look for via login on GitHub.
It's a unique
And
ID.
Let's make this a string that we pass in.
So we're using string interpolation.
I am going
and
to
we
pass
can
in the string
pass in that
here.
variable.
There we go. Perfect. So I have got some sort of a query written in text. What do I need to do next?
Let's make the call. Let's post it to GitHub. So http.post.
So let's get up a http.post. Again, this is all written in Dart. We can see here that post takes a URL, some headers, and a body.
Conveniently, we have a URL defined at the top of our file, so let's use that.
Because we're doing this from scratch, I've predefined a whole bunch of stuff here.
Remembering URLs is hard.
The only thing we're passing in here, the headers, as you can see, is an authorization token with my token, what I'm not going to show anyone here because that would be bad for me. And in the body, it's going to take the query.
Yes.
But GitHub expects that
in JSON.
In JSON.
So we should encode it in JSON.
Okay, I'm going to encode this in JSON, and I know that this expects a map that has a query parameter and takes a query, and I'm going to save that, and it's going to be nicely formatted. Great. Okay, so I've made a HTTP post. Not doing anything with the data.
So I know that the GitHub API sometimes is a little finicky about carriage returns and things.
Yes. So you can see here my multi-line query is a bunch of character returns. We found where we're using it. This is nicely formatted for visual, but GitHub occasionally complained. So I have written the greatest function name ever, which is called the remove spurious spacing. Try saying that after 2 beers. Which will just strip out most of the white space and leave it out. Great, so I have got my post.
Yes. All right. So now we have made a request to the server, and we want to get that result back. This might take a little bit of time. So we want to get that result. If you, as Matt's hovering over the post, you can see it's returning a future. So it will get information when it's available. Now, you can pass in a callback to be called when that future is available, or you can use the await keyword and say, don't proceed to the next line until this data is available.
And when we use await, we need to make our function asynchronous. And
Yes.
Dart is like JavaScript, and that's an asynchronous function, but it has built-in support for futures and things like that. So there we go. We now have this, and let's just print out the response body to actually show that this might do something, and hopefully it does
we should
something
call it
useful.
at the top.
Yes, and because I forget to do this every single time, I am going to change this. And you or me?
Let's do me.
Do you?
Yeah.
Okay. And I know that you are Fortuna on GitHub. Okay, there we go. So we got about 20, 30 lines of code there. That's great. Let's run this. And I know where this is here. And see what happens. And so the networking gods are with us. And this has returned a JSON payload. And as you can see, it's given us the user details, Emily's name, that really nice avatar that is what is a string.
Thank you, thank you.
And so the point of this was just to give you a quick demo of what does GraphQL look like, how we're going to use it. What I've done is I've built a simple package which has much more complicated queries like this. And what this query does is it goes out and it gets all of the pull requests for a user that has been asked to review those pull requests. So you can code up pretty complex pieces here. I'm not going to stand here for the next 20 minutes and mess around with things like that. So why don't we jump over to the app portion and see how you use this type of stuff to actually build out an app. I will close this down, and I will bring this up.
Cool.
I get kicked off at this point because, as Emily says, I
No
can't do UI.
UIs. No UIs. Banned from
thank you.
UIs.
Yes, great.
All right. So what we have here is a bare bones Flutter app. This is pretty close to what you get if you type Flutter create at the command line. It's pretty much nothing there to speak of. I will make note that we're running on an actual phone, and I just accidentally triggered assistance.
Okay, Google, go away. No, we didn't actually plan this. Hopefully that's still hooked up. Right, we'll find out in a minute.
So there's lots of functionality on this phone. We're not going to demo the assistant today, but instead, let's write this app. OK, so at the top, we have our main method, and we are running this my app, which is a widget, and that has a my homepage, which is also a widget. So all the pieces of a Flutter UI are made of widgets. So this AppBar you see at the very top, which is right here, that is a widget. This text right here, that is also a widget. If you wanted to center something, that you would wrap it in a center widget. This makes all of your components of your UI very composable and extensible. You can build them in ways that maybe the original API designer never dreamed.
And so the big thing to bear in mind here is that we're going to be creating new widgets, and we're going to compose them into a tree of widgets, which will render our UI. Let's demo this. Let's add a widget in quickly to somewhere. Yeah.
So right now you'll see also that each of these widgets has a build method, and that's what Flutter calls when it wants to draw it to screen. So in this app bar, we've got a title. Let's also add a little GitHub icon widget.
So AppBar is one of the many widgets you get out of the box with Flutter. It takes a bunch of parameters, one of which is leading. So what Emily is doing here is she has added an icon widget. She has specified the icon, and in the space of me yammering on, has saved, and it's already displayed the icon on the phone. Why did it just display the icon on the phone?
Yeah, so this makes use of hot reload. So all we have to do is we had the app already running on our phone, and it was able to see the new part of code that it didn't have running. You did a diff, and it just shipped that little bit of code over to the phone, and it's running. So it's your dev cycle is generally sub-second, which is refreshing.
So the thing to bear in mind here is that at the beginning, Emily said that Flutter is used to build native apps, which means they're running ARM code on device. And yet we're saying here now is we're pushing Dart code over to the phone when we're developing. That's because Dart has 2 compilation modes. It actually has more, but the 2 that we use. In release mode, we compile down, throw out VMs, get everything down to the bare minimum, and we have ARM code running on the metal at that point. But in the development mode, we're actually shipping a VM to inside the app to the phone, and that allows us to push Dart code and JIT it, which is why we get this hot reload. So this is one of the reasons why Flutter adopted Dart, is because we have these different flexible paths to give you a really good developer experience, but also to give you the native performance that you get when you compile down to bare metal.
Absolutely.
So, okay, we have basically an AppBar and a blank canvas. So first thing we probably want to do is we want to render the pull requests, or the reviews for the pull requests that we want to see. So what are we going to do?
All right, so let's add a body, and I'm going to call this fetch data widget.
So we have a scaffold widget, which gives us an AppBar. It gives us the basic structure of an app. And it takes a body, which is basically the white canvas. And what Emily is doing here is she is adding the fetch data widget. What is a fetch data widget? That sounds complicated.
It is a widget that I wrote just down here, but it's basically a wrapper around the future widget, which basically, because we're making a request to the server, we don't have the data just yet, so we're saying we're going to draw a little spitty waiting icon while we get the data, and once we have it, then we will draw the new widget.
Now, this is one of the nice things about Flutter, is we're layering in something here which is handling asynchronous communication and only rendering the data when it comes back. And we're encapsulating it in a widget. So our widget framework is actually very, very flexible. We can handle things like this. So we've given it a feature, which is please render the data that comes from the GraphQL API, which is a collection of review requests for pull requests. And in the builder, what we're going to do is we're going to supply it a function to run when the data has arrived. And that's just taking a list of pull requests, because that's what GraphQL is, the API is returning to us. And Emily is going to put those PRs into a mythical PR list widget, what doesn't exist yet.
Yes, so let's write that.
So, and here's another common pattern you'll see, is it's like we need to render something, we're going to create a widget to build around it, or reuse an existing one. So we're creating a pull request widget. In the constructor, we're going to pass in the list of pull requests. And so now we have those to render. And then we're going to modify the build method to say how we want to draw it. So how do we draw a list of stuff?
There's a ListView widget that is built in that would be pretty good for that.
OK. So again, we got a widget out of the box with Flutter, which is a ListView, which renders lists of items, but does it in such a way that if you have many of them or few of them, it handles all of the optimization for you. And what it takes is a list view expects a list of children. Guess what those children need to be? They need to be widgets. So we can't just give it the pull request. We're going to have to give it widgets that can render that pull request. So what kind of widget can we use to render a pull request?
Well, so we can take these pull requests and we can call the map function. Get all
OK, so we're going to go all functional programming now.
Yes.
OK.
And then we can take each one of those pull requests and convert them to widgets.
OK. So what we're doing here is, for this list of widgets, we're taking the pull request list, and we're going to map it into another list view.
List tile.
We're going to map it into a list tile, which is another out-of-the-box widget, which is a flexible widget with a bunch of controls that allow us to show some textual and graphical data. So basically, what does a list title take? It takes a title, and we're just going to, in the title, put in the title of the
pull request.
Pull request.
Yeah.
Cool. So there we go. So we have now gone from having a blank canvas to rendering a list. And this list would scroll. I mean, if we play with it, we can probably see the scrolly.
Look at that lack of scrolling action.
Wow, that's so amazing. Are we done? That's great. So now we've rendered. And this is actually pulled live data from
you. These are the pull requests that you are asked to review. You have some work after.
If we have time, we'll tell you about the interesting story where Emily auto-accepted pull requests, and there was much laughter from everyone except me. Don't give other people your token. So this is great. I can see the title of the pull request, but what repo does it come from? OK,
let's make this the subtitle, and we can make the repo the title.
Okay, so that's fine. We got a subtitle, but what we can do now is we know that our list tiles can take a title as well, and we're going to give that a title of the repo. And you can see we're not doing anything special. We're just writing the code. We're saving it. It's now rendering actually on the real device. Perfect. So I can see that we have dude, where's my pull request to the repo?
The wumper.
And we have Flutter the repo. I would really like to see and be able to triage about how important, how many stars do these have?
OK, so we can add this trailing feature. And I wrote ahead of time this star widget, which I will show you in 1 second. It's very easy, but I am lazy when it comes to typing.
So we're going to put trailing. It's probably going to be at the end of a list tile. And we're going to pass it just the count of stars. And there we go. We have dude, where's my pull request has 3 stars, and Flutter has 32,700. So we got a ways to go with ours. But anyway.
Yeah. Star my repo.
And so here we are. We're composing up our UI. So we're now at a point. Do you want to talk a little bit about the star widget?
Yeah, I just want to show you that there's no magic going on here. It's just another widget made up of other widgets. So our star widget has a build method. It has 2 things. We have our star icon, and we have text, which just does this pretty printing for large numbers, like the Flutter repo. And then we wrap it in a row so that you can put those 2 widgets side by side.
Widgets within widgets within widgets. Great. We're at a point where we have a rather unexciting list of reviews. What I would really like to be able to see is the diff, so I can work out whether we want to accept these or not. So how are we going to do that?
How about when you tap on it, you can go to a different page.
So we have no tappy functionality at the moment, but fortunately, our list tile gives us an on tap, which we provide a function to.
Oops.
And what Emily is doing here is she's calling this show review method. And all this does, this is saving us a little bit of typing. Flutter has built-in support for navigators. So this is a navigator, which is going to basically push to a new screen. And the screen is going to render this review page. This is going to look like Android because we're running on Android. If we were running on an iPhone, the navigation would look and feel like Apple's navigation. So we take care of all of that for you. So on the on tap, we're basically going to push a new page to the navigator. And so do we have? OK, there we go. So great, we have a new page. It looks like our page doesn't do much yet.
Yeah, it's pretty boring. It's here's the review page, and it looks pretty much like what we started with before. We just have a scaffold and an app bar.
Great. So we have a new page, but into the constructor, we've passed the pull request diff. So why don't we, this is another new scaffold like we've seen before, which is going to be able to take a body. So we can push, or we can display our pull request diff in there. And so there we go. That was easy. I mean, I see you're using the a-style code function, and you're returning a rich text widget. What do we need to do here?
So this is another case of the code is not hard, but I'm not typing at all. But so unfortunately, because we're on a phone, we can't do side-by-side diffs. Our phones are not that wide. But we can do inline diffs, and we can color them to make them very readable. So it's pretty simple little thing, just like you would get on a good old terminal. If you have your plus sign, make the color green, minus, have it red. And then you have a monospace font for reading that code stuff.
Perfect. So can we scroll through the diff and take a look?
Not yet.
Oh, OK. So we can't scroll through the diff because rich text doesn't scroll. So what are we going to do to solve that, I wonder?
We can wrap it in a bidirectional widget. Because, so there are, you can scroll one direction. And some widgets allow you to scroll one direction only. This one, because our phone is 80 characters, is on a view would be pretty tiny. We're going to let you scroll both directions.
The cool thing here is the Bidirectional Scroll View plugin is not out of the box. This is actually coming from a third-party package, which identified that they wanted to scroll to multiple directions. And so instead of making us write multiple scroll things, we've pulled it in. And this is kind of the thing, is it's like at the moment, there's usually a widget for the type of thing you want to do, and this is very specialized. And if we haven't provided to you out of the box, the community is filling these in with, we needed to do this, we didn't want to write it. Emily found the bidirectional widget. We're like, great, let's just use the bidirectional widget. We have a package management system, which if you're familiar with Node.js is kind of like NPM called pub. We simply specify it in pub spec, and then it will pull the appropriate packages in. So we can now scroll around. So we've gotten to the point. We've got a list of pull request reviews. We can now look at the diff. but we still can't accept.
Yeah, and this looks like a pretty good diff, or a pull request, so I would like to accept it. So
this is how we do our review process.
This is, yeah.
That looks good.
Scroll.
We're good. Let's just, wait, this is my key. Yeah, okay, fine. So we are going to, the scaffold has support for embedding a floating action button. We're going to create a new floating action button widget. We're going to give it an icon to represent within the floating action button. And I imagine it's also going to take some sort of, that's probably going to be a call.
Oh, this is what I did last time.
Yes, this is what you did last time. Joys of live coding. So this actually takes a function and not directly that. And so we have a floating action button.
So here, I'll save this. What I just did is instead of, I called accept pull request on the pull request that we were viewing instead of only doing it while on pressed. And so we've auto-accepted that pull request.
So what we have, okay, the funny
this is
thing
how
here,
you get into trouble.
This is not intentional. And we did exactly the same thing the last time we rehearsed this and going, we're never going to make this. So what we've actually invented is an app which does pull requests for you.
Accepts everything.
It just accepts.
Your code
it's
is
like,
all great.
Computer says yes. It's great.
Okay, so what are we
going to do next?
So what just executed is we called GraphQL to accept the pull request, and then we called navigator.pop to go back to the previous page. And so let's hop over to, as you can see, this is the repo that we're developing in. We had 2 pull requests. I think the one I just accepted was this fancy floating action button. So I'm going to refresh this, and we should see 1. All right, well, let's look at the closed ones. And look, a minute ago, Matt Sullivan. What a silly idea.
The thing to note here, though, is that we've actually gone from, like, we have the GraphQL API, but we've pretty much built up an app fairly quickly, with a couple of helper functions, admittedly, to be able to do pull requests. Now, as you can see, which is what we intended to show you at the beginning, is here is a floating action button, and when we tap on that now, that will accept it, but I don't think we're going to do that.
Yeah, I'm not going to accept it right now.
So imagine, if you will, it didn't auto, but we tapped on the button. So we have now accepted a pull request for a fancy floating action button. This is where things are going to get meta. And we have committed this to the same repo that this project is based on. So we are going to attempt to pull down that commit
from GitHub
into the app to make use of the commit that we did through the app.
Yes. All right. So
has anyone seen Inception?
I have great commit messages.
Okay, we're going to get our changes. We're going to pull down the latest.
Okay. So let's see what I blithely accepted without even looking at here. This fancy fab widget is yet another widget. It's a little more complicated, but here, let me stick it in, and we can see what it does, and then I'll talk about it.
So basically what happened, Emily created a fancier version of the fab earlier. It's a direct swap-in for a floating action button, so we can use that. And then if we flick over.
Oh, thank you. I need to show this. Okay. So as you see, the little check mark changed into this little code angle brackets, and now when I tap it, look at all these little buttons that come up.
Ooh, pretty.
So a couple things going on here. First, if you want to accept the pull request, you can do the little check mark. If you want to close it because you're like, nah, that's no good, that's a cancel. And if you know how GitHub has all those great reaction selections that you can act, well, because you're on a phone, I mean, typing comments, that's too hard. Just like react to pull requests. That's the new code review my emoji is the
code
new
review
way.
by emoji. So if, let's say, we love this pull request.
Yeah, but first I want to take a look at, explain about how this works.
Oh, you want to look at the actual? Okay.
Yeah, so fancy fab, just to give a little highlights on how this works. We're doing some animations here. There are 2 main animations that happen. The first one is we have some scaling, which, yes, here we go, scale animation. And that's for the top set. So you see we have this column. That's for all of these buttons. They're in one long column. The scaling is for all the white buttons so that they grow and shrink as we tap. The second animation is down here, and it's the rotate animation. And so that's for that bottom button that as you tap, you see how the X spins as it closes and opens. And the other cool thing is we have, so we say the angle, we specify how much to rotate, it's in radians. And with the animation controller, you can say whether you go forward and reverse. You only have to code one direction, and then when you want to do the opposite, you just go, it just shrinks or grows as needed. Okay, so now you want to make use of our reaction.
I'd love to see this in action.
Okay, so what do we think of this pull request that we have so carefully reviewed?
I guess we're going to love it, are we?
Okay.
Yes.
Hold on, let me show you the pull request so you can see that there's nothing, nobody loves it yet.
It's a much hated pull request.
Nobody. Somebody please love this. All right, so here we go. Loving.
Yay, a heart. There we go.
Okay, so since someone loved it,
We're going to go further?
do we want to commit it?
Yeah, let's go for it.
Okay. All right, so just to make sure that this fancy fab works completely, we're going to go ahead and accept that.
So you use the pull request for the repo that created the pull request to create another pull request to pull it down to add more functionality.
Yes.
Okay, cool.
All right, so that pull request added a user banner. Oh, and it added some user functionality so that we can see that avatar URL instead of just looking at that URL itself. We can look at the actual picture. And so we have the user banner plus users and PRs. So I'm going to swap out fetch data widget, which is still called under the hood.
And so again, this is kind of another example of how we built up something and we put a bunch of widgets in there, but now we've introduced new functionality and we're adding new widgets. So at some point, I'm going to show it on the screen.
Oh, that would be useful. I'm sorry, I'm shortchanging our hot reload. Here we go. Ta-da!
And there we go, we have that. So,
do you want to show how this works on iOS?
Do people want to see it running on iOS? Yep.
All
Okay.
right.
So let's put. I got the simulator running, and we can switch what we're pushing to. So what you'll see here is when we first run a Flutter app, it's going to take a few seconds to run because it's got to go and go. I got to do the Android compilation. I got to create the APK. I got to pull everything in. I got to get it on the phone. It takes a little bit. After that, we are pushing code over as we change it. So what's happening now is this is compiling up using Xcode under the hood. And there's the simulator running on here. And it will, hopefully, at some point, render this onto the phone as well. So first startup can take a little bit. But then once you have it running, you have the code pushing and pulling. And we can compile to both platforms. And again, on both platforms, when we do a release compilation, it will compile it down to native code. So there we go. And if we click on one of these, you'll see that the navigation is iOS style. It's not Android style. And the scrolling is going to be on the front.
Oh, yeah.
When you scroll it, you'll get the bounce effect, and you're not going to get the Android inkwell effect. So we take care of that for you. Oops. So there we go. In the space of, we got 5 minutes left. This is great. In the space of 30 minutes, we've built this up. We've accepted, pulled a few pull requests. We've got it running on both devices.
Unintentionally and intentionally.
Unintentionally or unintentionally. We have the source code available in Emily's GitHub account at eFortuna/dude, where's my pull request, Dwumper. And there's a bunch of other resources that you can look at. You can go to the Flutter.io website where there's a bunch of technical documentation. Obviously, our code is up on GitHub. We have some code labs if you want to start to try out Flutter. And if you want to chat to the engineering team and other people using Flutter, then we have a Gitter channel as well, which allow you to do the IRC style thing. And thank you very much for listening. We have 2 or 3 minutes if people want to ask a couple of quick questions.
So yeah, we programmed in Dart. It is similar in style to JavaScript or Java, C#, any sort of C-style language.
So if you had to write custom logic, what is it basically writing JavaScript? Like, business logic?
Yeah. And I always like to tell the story. When I first started working on the Dart team, I didn't know Dart, and I came from like the Java world. And when I just started programming as if I was programming Java, and it works. And then once you learn more, once you get comfortable with that, you can learn more about Dart, and there are nice idioms to make it more concise. But yeah, it's quite easy to pick up.
Yep, built into Visual Studio Code and Android Studio. We didn't have time to show it, but you can do the breakpointing thing. You can delve into your stack traces. You can inspect widget trees and everything else.
And you can also use IntelliJ or Android Studio. Like really, there are many different plugins on your IDE of choice, including Vim.
Cool.
You said we could dive into the internals. Could we look at like how the title bar is?
Totally.
Sure. I mean, we can go back to the code, and we can go to the AppBar, and we can.
Here, I'll let you.
We can basically right-click on it. We can go to the definition. Here is the source code for the AppBar. Here's all the style documentation that you would get through the web. I can dig down through here. I can see all the elements that it has. I can dig into the source code for it. And so this is all the source that's available for it. And then you can dig into others as well. And I can go, well, what does the navigation toolbar look like? I'll go to the definition there.
And when I wanted to implement my own AppBar or something, I look at the original source. I'm like, oh, let me just tweak it, something similar. So yeah, it's great for inspiration.
Mm-hmm. Sorry.
So it looks like right now it's mobile only. Is there any intent to bring it to desktop?
So way back here, we have experimental embedders for Linux and Mac. The reason they're experimental is because we really want to get the mobile experience right. So we've started with iOS and Android, but we run stuff on Mac OS. And it's not, I would expect there to be things like Windows embedders and stuff in the future as well. If not from us, then certainly from the community. Yes, and we have a whole plugin architecture where if you want to communicate with native code in Kotlin, Java, Objective-C, Swift,
yeah.
We have channels that can do that. And behind the scenes, you can, in your native code, then introduce different pods and have those pulled in automatically by our package management system.
There are a number of companies that are using Flutter, and they mixed it with their native app as they're transitioning to Flutter.
Cool. So we'll grab two more. So if you look under the hood, there is a single Flutter activity, which is created. But we're doing a lot of work at the moment to allow you to embed Flutter into existing Android apps, and that will give you the capability of creating multiple activities or multiple views that are Flutter rendered rather than Android native rendered. So we're doing a bunch of work, and you'll see the outcome of that over the next few months. But you can always drop down to the Android level. You can see where we're creating the main activity to start the rendering, and you can add your own activities in at that point if you want to mix and match.
Does Flutter have anything for managing application state, sharing data between widgets?
Yes. So
there's a talk that
there's a whole
Matt
talk if you look at the I/O
month
videos.
Or so ago, yeah.
So you saw us use stateless widgets. There is a thing called a stateful widget, which will handle state for you.
Which that fancy fab was a stateful widget. We didn't get into that, but.
And there are implementations of Redux that work well because it's the same type of reactive programming. We have there are 3 or 4 different packages. If you go onto GitHub and look for IO 18 and state management, there's a talk. We have some articles on it as well. So you have a number of choices there. The way we recommend doing it at the moment, our strong recommendation at the moment, is to take a look. Dart has a really good streaming API. And we've created some widgets that allow you to manage streams. And it's a very elegant way of handling data through your app by listening to changes in streams or pushing data into streams. But if you prefer things like Redux or whatnot, you can go down that route as well. Very quickly, one more.
So is it Dart that has a package manager?
We use the Dart package manager.
Under the hood, it's Darts. Flutter uses it as well.
And the Flutter command line tool uses pub behind the scenes to pull all of it in.
But yeah, we'd love to answer more questions. We can out in the hall. But yes,
Yep.
thank
So
you
we'll be
so
around
much for
for it.
coming.
Thank you very much.